In this video, we're going to follow up and learn more about equivalences, and there are some versions of statements that are complete equivalences, and if we recognize them, then we don't have to compare them using truth tables to see if they're true. One equivalence here that actually doesn't really have a name, it's just a true fact, is that if you have an if P then Q statement, that's equivalent in every way on a truth table to not P or Q. So that was just kind of a fun fact, I guess I'd say. That has nothing to do with the rest of it, but it may be helpful to you. The main focus of this table and this note here is to talk about these related conditional statements. So we have the conditional statement if P then Q. We're familiar with that. So if you reverse the order and you say if Q then P, that's what we call the converse. And you may have actually heard that in spoken English sometime when someone says something. They may say, well, the converse of that is true. Because you might make a conditional statement and they come back that there's a converse that's true. And then another version is if we keep it in the same order, if P then Q, but then we negate both sides. If not P, then not Q. That's what we call the inverse. And then finally, we have the contrapositive, which is we reverse the order of the two pieces of the argument, and we negate them. So if not Q, then not P. And what happens here is if you build out truth tables, which they have done here for us, you realize that the conditional statement gives true, false, true, true, and the contrapositive gives true, false, true, true. So we would say those two arguments are equivalent. So if you ever see if P then Q, and then you see if not Q, then not P, you realize that those two are the exact same equivalent statement. And likewise, if you build out the converse and do your truth tables, you realize the converse and the inverse have the same truth values to them. So that's what this little box here describes, is that a conditional statement and its contrapositive are equivalent, and the converse and inverse are also equivalent. So let's come down and look at this example. We've talked about it before, but it says if P is you live in Houston and Q is you live in Texas. So as an if-then statement, we could say if you live in Houston, then you live in Texas, and that makes sense. And we also learned that there were some varieties to a conditional statement. You may say necessary or sufficient and change the order up. Now, these different versions of that conditional statement have nothing to do with the contrapositive and inverse and converse in this example. These are alternate ways of stating a conditional. So I don't want to get the two things confused here. The reason we need to review this right now is because when you get to a problem on your homework, you're going to get a statement like this problem here. And it says, all states have capitals. So if you look at our variations on the conditional statement, it looks a lot like that one. All residents of Houston are residents of Texas, which means that the first part is the P and the second part is the Q. So if we come down, we have all states have capitals. What's the correct if-then statement? So the correct one is if something is a state, then it has a capital. All right, so if it is a state, then it has a capital, and we would choose B. So that's our plain conditional statement. We've not altered it in any way other than to realize the wording gives an alternate interpretation. So now we're going to actually alter the statement. Which statement below is the correct converse? So recall that converse is when we reverse the order of the argument to say if Q, then P. That's the converse. So instead of saying if it is a state, then it has a capital, we're going to bring the capital part forward and say it first. If something has a capital, then it is a state. So that would be the correct converse. All right, the correct inverse. So look again. Inverse, it says if not P, then not Q. So if something is not a state, then it does not have a capital. So if something is not a state, then it does not have a capital, and that would be answer choice A. And finally, the contrapositive. Let's go look one more time. Contrapositive is if not Q, then not P. So let's come down and look at our statement again. If it does not have a capital, then it is not a state. So if something does not have a capital, then it is not a state. And that would be answer choice B. So this is a pretty simple little topic, just designed to introduce you to the concept of a converse and an inverse and a contrapositive.